Welcome back, everyone. So we will continue with the clicking. Um, we stop with pointer, so that's mouse buttons and controls. Letter B. While the user holds the cursor over a target, he clicks and he releases the mouse button. In general, the action is defined to trigger a state change in a control or selecting an object. So in a button, this mouse down or clicking trigger a state change on that object. So you need to actually program that in the backend in a matrix of text or cells. The click means bring the selection point over here. For a push button control, a state change means that while the mouse button is down and directly over the control, the button enters and remains in the push state. When the mouse button is released, the button is triggered and its associated actions occur. So design principle, single clicking selects data or an object or changes the control state. So for a matrix or a cell, when you click that, it actually just point and then hover the text where you will type. While in the push button, it enters a state. Then when you release that, that's the time when the button is triggered and its associated action that was triggered in the backend or that was programmed for it to do is released. However, if the user moves the cursor of the control while still holding down the mouse button, the push button controls return to its unpushed state, but the input focus remains on the control until the mouse button is released. When the user releases the mouse button, input focus is severed and nothing happens. So, I know you guys, like when you click something and then suddenly change your mind, you just need to hover that mouse in another position, then release it, and it will not trigger the button that you've pushed. So that's what it meant. Point and click combination. You can perform two basic operations with the mouse. You can move it to point at different things, and you can click the buttons. The following list summarize the complete set of mouse actions that can be accomplished without using modifier keys. So modifier keys are the shortcut commands. So usually you can only hover your mouse and then or change the position and then click. But these are actually the things that you can do with your mouse. There's a 7 permutation. First, point. Second point, click left button, release click. So that's what's the normal click point. Click right button, release right click. Point, click and hold down left button, drag, release, click and drag. Point, click left button, release, quickly again, click left button, release, double click. Then point, click left button and right button simultaneously, release both buttons, so that's chord click. Point, double click without releasing the mouse button, drag, release, double drag. Clicking and dragging, the versatile operation has many common uses, including selecting, reshaping, repositioning, drawing, and dragging and dropping. As with clicking, it's often important to have an escape hatch for users who become disoriented or have made an error. The Windows scroll bar provides a good example of this. It allows user to scroll successfully without having the mouse directly over the scroll bar, as long as it was first click within the scroll bar. So once you click within the scroll bar, you don't need to um, click the that again. So that's a program. Imagine how hard it would be to use if it behaved like a button. However, if the user drags too far from the scroll bar, it reset itself to position it was before being clicked. So there's a lot of things that could be done in just clicking and dragging. And there's this is the rules that idioms that we use to be able to make a lots of command in short period of time. This behavior makes sense since scrolling over long distances require gross motor movements that make it difficult to stay within the bounds of the narrow scroll bar control. So that rule makes sense or reasonable because scrolling over long distances require our gross motor movements, which we've discussed is provides a lot of exercise. If the drag is too far off base, the scroll bar makes the reasonable assumption that the user didn't mean to scroll. So if it's too far, the program will assume that you didn't mean to scroll, which is smart because that's the normal usage of the application and more natural. Some applications set this limit too close, resulting in frustratingly temperamental scroll behavior. So sometimes it was not set properly. The limit is too close, so it results in temperamental scroll behavior that was not intended by the user. So instead of the user having this motor and fine grain exercise remove, it's actually made it worse. Clicking and dragging on a trackpad, while possible, is hardly ideal, especially in the scenario just described. Drag actions on capacitive surfaces aren't as robust as mouse dragging, and the relatively small surface area of most trackpads doesn't help. So clicking is not as robust as this mouse, which we usually used in desktop or laptop. So that's why trackpad it provides less exercise. That's why even though we have a trackpad already, we still use mouse because that's the right tool for the right application. Double clicking. If double clicking is composed of single clicking twice, it seems logical that the first thing double clicking should do is the same thing that a single click does. This is indeed its meaning when the mouse is pointing at data. Single clicking selects something, double clicking selects something, and then take action on it. So the control is designed to invoke an event or action once it clicks again. So click means selecting it, and then double clicking means invoking the action. Here double clicking means single clicking plus action. This fundamental interpretation comes from the Xerox Alto by way of the Macintosh, and it remains a standard in contemporary GUI applications. The solution to this accessibility problem is to include double-click idioms, but ensure that their functions have equivalent single-click idioms. So double-clicking must be, generally speaking, double-clicking should be avoided, where a single click would suffice. Chord clicking. Chord clicking means clicking two buttons simultaneously, although they don't really have to be clicked or released at precisely the same time. To qualify as chord click, the second mouse buttons must be clicked before the first button is released. So the other button or either button must be released to qualify the cord clicking. Cord clicking can be done in two ways. The first is the simplest. The user merely points to something and clicks both buttons at the same time. This idiom is clumsy and has not found much currency in existing software, although some creative and desperate developers have implemented it as a substitute for the shift key on selection. The second method is using cord clicking to cancel a drag. The drag begins as a simple one button drag, and then user add the second button. Although this technique sounds more obscure than the first, it actually has found wider acceptance in the industry. So using cord clicking as a cancel when you have made a drag is accept a wider acceptance in the industry. Double clicking and dragging, like triple clicking, it's useful only in specialized sovereign applications. Use it as a variant of the selection extension. In Microsoft Word, for example, you can double click text to select an entire word. So expanding that function, you can extend the selection word by double dragging. In a big sovereign application that has many permutations of selection, idioms like this one are appropriate. So it's rarely used. It is only fit for a sovereign application. Mouse up and mouse down events. Each time the user clicks a mouse button, or double clicking and dragging is like, when you double click and you drag. So actually for Microsoft, they have this when you double click a text like an entire word. So expanding that function, you can extend the selection word by word by double dragging. So I think it's like here when I double click and then I drag. So it doesn't have that much functionality. Mouse, each time the user clicks the mouse button or taps a trackpad, the application must deal with two discrete events: the mouse down event and the mouse up event. Within a given product and ideally a platform, this action should be made rigidly consistent. So this mouse down and up or clicking should be consistent in your application. On the other hand, if the cursor is positioned over a control rather than selectable data, the action on the mouse down event is tentatively activate the control state transition. So the action on this event of the mouse actually controls the state for this icon or control button. When the control finally sees the button up event, it then commits to the state transition as shown in figure 18.16. These images depict feedback and state change of checkbox in Windows 8. The first image shows an unselected checkbox. The second, mouse over state or hover. The third shows the feedback to the click or mouse down. The fourth shows what happened when the button is released, mouse up, but with a hover. The final image shows that the selected state of the checkbox without a box. Notice that although the click has visual feedback, the checkbox control doesn't register a state change until the mouse release. Design principle, mouse down over control means proposing an action. Mouse up means committing an action. This mechanism allows user to gracefully bow out an inadvertent click. After clicking a button, for example, the user can just move the mouse outside of the button and release the mouse button. So this actually mechanism help them to prevent errors. So it's like on the forgiving or undo principle, like you need to allow your user to fail to be able to learn it faster. For a checkbox, the meaning is similar. On mouse down, the checkbox shows that it has been activated, but the check doesn't actually appear until the mouse up transition. This idiom is called preempt response hinting. So on mouse down, the checkbox shows that it has been activated, but the check doesn't actually appear until the mouse has been released. So that is called preempt response heating, since it indicates that you were able to click it. Trackpads, trackballs, and gesture sensors. Keep in mind that trackpads are a bit more prone to glitchy behavior than mice, since they rely on finger contact on their capacitive surface, and the drag and drop or fine positioning control are difficult. This shouldn't affect your design of typical desktop app much, but it's something to consider if you know your users will be making heavy or exclusive use of trackpads. So trackpads are not actually used by usual users. So drag and drop for this are difficult. Trackballs are uncommon but are still used for specialized applications where fine movement control is desirable and space is at a premium, or where the ball's rotational movement maps well to manipulation of objects on screen, 3D modeling applications. Click and drag operations are somewhat awkward using trackball. So any dedicated application using a trackball input should be designed to minimize the need for such interactions. Mice and trackpads with multi-touch gesture sensors are becoming more and more common and are the standard for Apple computers. The operating system typically reserves supported gestures for its own use, but in the event that gestures are made available for use by your application, think carefully about their implementation. Such gestures shouldn't interfere with OS gestures without excellent reasons, and they shouldn't be the primary method of accessing functionality or performing navigation. So there's actually a trackpad and mice that has multi-touch gestures, which has standard integration with Apple, but it should not be the primary gestures because of its difficulty of using. So cursors, pointing and selection on the desktop are achieved via the cursor, the visible representation of the mouse position on screen. By convention, it is normally a small arrow pointing diagonally up and left, but under application control, it can change to any shape as long as it stays relatively small, 32 by 32 pixels on Windows 8. So here the arrow, I'll put that on letter D. So that's the diagonal pointing arrow. Because the cursor frequently must resolve to a single pixel to point at small things, there must be some way for the cursor to indicate precisely which pixel is the one pointed to. This is accomplished by designing a single pixel of any cursor as the actual locus of pointing, called the hotspot. So here is the hotspot pointing to letter D, so that you are able to click accurately. For the standard arrow, the hotspot is logically the tip of the arrow. Regardless of which shape the cursor assumes, it always has a single hotspot pixel. So, regardless of what shape of your arrow, it should only have one pixel. As discussed, the key to successful direct manipulation is rich visual feedback. It should be obvious to users which aspects of the interface can be manipulated and which are decor. Especially important for creating effective interaction idioms is attention to mouse cursor hinting. Selection. The act of choosing an object or controls is called selection. This is a simple idiom typically accomplished by pointing to and clicking the item in question. Although there are other keyboard and button actuated ways to do this, selection is often the basis for more complex interactions. So pointing and clicking is actually the selection and the basis of more complex GUI interactions. So it is the act of choosing an object on the screen. After the user chooses something, she is in the appropriate context to perform an action on that thing. The sequence of events implied by such idiom is called object-verb ordering. So here's we're gonna talk about now that this object verb, in which in a physical world we usually start with uh, we may think that we will gonna start with a verb to make an action on the object, but as we will later see, we need to choose an object first before verb, because if you choose an object, you can perform multiple actions on it. So that's actually easier to learn for GUI. In the real world, however, or in English, in describing English, you actually start with a verb and then object, because those are more natural. You want to start with some action in the object. If you think about it, if you can express a command in two ways, uh, with the verb first followed by the object, or with the object first followed by the verb, throw me that ball versus that ball, throw it to me. These are commonly called verb object and object verb orders. So it's not natural to say that ball, throw it to me, but for GUI, it's natural. Respectively, as a result, it was only logical that command line systems mimic this structure in their syntax. For example, to remove a file in Unix, you type rm filename.txt. Without the rigid formal structure of command line idioms, graphical user interface must use the construct of state to tie together different interactions in a command. So the GUI actually use the construct of state to tie the different actions. If the user chooses a verb, the system must then enter a state, a mode, to indicate that it is waiting for the user to select an object to act on. So if the user chooses first the verb, then it will enter a state, because in an action you're doing something, so you're in a mode, and then you need to choose the object that you will apply the action. In simple case, the user then chooses a single object and all is well. However, if user wants to act on more than one object, the system can know this only if the user tells it in advance how many operands he will enter, or if the user enters a second command indicating that he has completed his object list. So in simple, to explain this further, the only way for the system to act like multiple commands or verbs to an object is actually to predefine that verb in advance. So many times in an application, you are not aware on the verb that you will apply or the action that you will apply to the object. So the system needs to be adaptable. Or you can actually perform the verb to the object unless you're done with the first verb, because it must enter the state first or you must finish that cycle. With an object verb command order, we don't need to worry about termination of that state. Users select which objects will be operated on and then indicate which verb to execute on them. The application then execute the indicated function on the selected data. So that's actually how we use the function. You select the object that you're gonna use the verb or the function, and then that function apply to that data. A benefit of this is that user can easily execute a series of verbs on the same complex selection. A second benefit is that when the user chooses an object, the application can show only appropriate commands. This potential reduces the user's cognitive load and reduces the amount of visual work required to find the command. So once you click the object, the application can provide you immediately the available command or icons that you can apply to that object. So that reduces cognitive load that used to be need to be remembered before in a command line system. So it also reduces the amount of visual work required to find the command. In a visual interface, all commands should be represented visually. Notice that a new concept has crept into the equation, one that doesn't exist and that isn't needed in a verb object world. The new concept is called selection. So this is the basis of all the interaction for this direct manipulation or GUI. The object verb model can be difficult to understand in the abstract, but selection is an idiom that is easy to grasp, and once shown is rarely forgotten. Clicking an email in Outlook and deleting it, for example, quickly becomes second nature. In interfaces that don't employ direct manipulation, such as some modal dialog box, the concept of selection isn't always needed. Dialog boxes naturally come with one of those object list completion commands. So in interfaces that they don't employ direct manipulation, such as modal dialog box for back menus or functions, dialog boxes naturally come with one of those object list completion commands. So in that case, we can use the object because uh, uh, we can use the verb to manipulate the object because those are just a dialog box. So a verb object is more applicable for a dialog box as the OK button. Here, users may choose a function first and one or more objects second. So in the dialog box, you choose a function first before you choose one or more objects. While object verb orderings are more consistent with the notion of direct manipulation, there are certainly cases where the verb object command order is more useful or usable, such as in maps where you don't know where you will go. So you don't know the object yet, but you know that you're gonna go there. Discrete and contiguous selection. Selection is a pretty simple concept, but a couple of basic variants are worth discussing. Because selection typically is concerned with objects, these variants are driven by two broad categories of selectable data. Both contiguous selection and discrete selection support single-click selection and click and drag selection. So both of this data support single click and drag selection. Single clicking typically selects the smallest useful discrete amount, and clicking and dragging selects a larger quantity, but there are other significant difference. So for single clicking for this type of data, so contiguous is like this, a word in OneNote. So it's like a contiguous data. For icon, so those are the things that we see in here, like insert space. Sorry, that's not an icon here. So these are the icons. So those are the two types of data. So usually when you click that, you need in this desktop app, when you click that, A single click means selecting a single piece of data, while clicking and dragging usually means huge data. In some cases, data is presented by distinct visual objects that can be manipulated of other objects. Icons on the desktop and vector objects in drawing applications are examples. So, in some cases, actually, for these icons, you can manipulate this independent of others, right? So you can click this, without affecting the other. These objects are also commonly selected independently of their spatial relationship with each other. Discrete data, on the other hand, has no inherent order. Many meaningful orders can be imposed on discrete objects, such as sorting a list of files by their modification dates. So these actually type of data are selected based on their position or spatial. Now, discrete data on the other hand has no inherent order. Actually, this is a discrete data as well. This is what we call discrete data. It's an icon. It's a different from this contiguous data, which is the word. Many meaningful orders can be imposed on this, such as sorting a list of files by their modification date. So we can sort this in their modification dates by programming it in the backend. However, lack of single inherent relationship means that users are likely to want to make discrete selection, such as control clicking multiple files that are not listed adjacently. So because of that, we tend to use control and then click that and then click other icon as well. Of course, users may also want to make contiguous selection based on some organizing principles, such as the old files at the bottom of that chronologically ordered list. The utility of both approach is evident in a vector drawing application such as Illustrator or PowerPoint. In some cases, the users will want to perform a contiguous selection on objects that are close together, and in other cases, she will want to select a single object. Conversely, some applications represent data as matrix of many small contiguous pieces of data, like this text. The text in a word processor or the cells in a spreadsheet are made up of hundreds or thousands of similar little objects that together form a coherent whole. These objects are often selected in contiguous group, so we call them contiguous data, and selection within them contiguous selection, such as here. When I double click here, I click this group of data. So these are actually object. In each word of this is object. There is a natural order to the text in a word processor's document. It consists of contiguous data. Scrambling the order of the letters destroy the document sense. The characters flow from the beginning to the end in a meaningful continuum, and selecting word or paragraph makes sense in the context of the data. Random disconnected selections generally are meaningless. So random selection for this are meaningless because the combination of this data is what's important, unlike those that icon only. Theoretically, it is possible to allow a discrete, discontinuous selection, such as several disconnected paragraphs. However, the user's task of visualizing the selection and avoiding inadvertent, unwanted operations on them is more trouble than worth. So, yeah, this could be used as well to select different or unrelated data. but it's more trouble than worth, so it's not really used by common users. Mutual exclusion. Typically, when a selection is made, any previous oh my god. So that's one of the usability issue of that. Mutual exclusion. Typically, when a selection is made, any previous selection is unmade. This behavior is called mutual exclusion. Typically, the user clicks an object and it becomes selected. That object remains selected until the user selects something else. Mutual exclusion is the rule in both discrete and continuous selection. So it's a rule in this in both of this data. Some applications allow users to deselect a selected object by clicking it a second time. This can lead to a curious condition in which nothing is selected and there is no insertion point. You must decide whether this condition is appropriate for your product. So some products are actually map this click, in which when you click it again, it will deselect it. Additive selection. Mutual exclusion is often appropriate for continuous selection because users cannot see or know what effect their actions will have if selection can readily be scrolled off the screen. So, a mutual exclusion is actually appropriate for the contagious selection, meaning that the users cannot see or know what effect their action will have if selections can readily scrolled off the screen. Selecting several independent paragraphs of text in a long document might be useful but isn't easily controllable. It's also easy for users to get into situation where they cause unintended changes because they cannot see all the data they are acting on. So if the mutual selection is applicable, if you cannot see all the options that you are clicking, that you cannot visually see the effect uh, in data, such as those long document that has scrolling. Scrolling, not contiguous selection, creates the problem, but most application that manage contiguous data are scrollable. However, so actually the scrolling is the issue, not the mutual exclusion or contiguous selection of data. However, if there is no mutual exclusion for interactions involving discrete actions, the user can select many independent objects by clicking them sequentially, what is called additive selection. A list box, for example, can allow users to make as many selection as desired and to deselect them by clicking them a second time. So a list box allows you to check multiple objects or a box. Most discrete selection systems implement mutual exclusions by default and allow additive selection only by using a modifier key. So most these icon based, which is most application, use actually a mutual exclusion by default, and they only use this additive for as a modifier key. In Windows, the shift key is used most frequently for this task. In contiguous selection, the CTRL key is frequently used for discrete selection. In a drawing application, for example, after you've clicked to select a graphical object, typically you can add another one to your selection by shift clicking. So Windows actually use control to like that. Let's Others use a shift to click multiple contiguous or objects, such as a drawing application. So interfaces employing contiguous selection should not, generally speaking, allow additive selection. At least not without an overview mechanism to make additive selection manageable. However, contiguous selection interfaces do need to allow selection to be extended. Again, modifier keys should be used. So, if you can't implement this additive, since you're using this selective data or icon data, you must provide an extension using modifier keys. In Word, the Shift key causes everything between the initial selection and the Shift click to be selected. So let's try that, and then click here. As you can see, some list boxes as well as the file views in Windows, both example of discrete data, do something a bit strange with additive selection. They use CTRL key to implement normal discrete additive selection, but then use the Shift key to extend the selection as if it were contiguous, not discrete data. In most cases, this mapping adds confusion because it conflicts with the common idiom for discrete additive selection. So control key are used for discrete data to select multiple data, and then Shift to extend it. Group selection. The click and drag operation is also the basis for group selection. For contiguous data, it means extend the selection from the mouse down point to the mouse up point. So the click and drag is actually here. You can actually create a box to choose multiple things in File Explorer. So this can also be modified with modifier keys. In Word, examples, control click selects a complete sentence. So control drag extend the selection by sentence. So let's try. So if you so those are the idiom. In a collection of discrete objects, the click and drag operations generally begins a drag and drop move. So if it's a collection of discrete objects such as this, the click and drag operation generally begins a drag and drop move. If the mouse button is clicked in an area between objects, rather than on specific object, it has special meaning. It creates a drag rectangle as shown in figure 18.17. So when the cursor is not on any particular object at the mouse down time, the click and drag operation normally creates a drag rectangle that selects any object wholly enclosed by it when the mouse button is released. This is a familiar idiom to users of drawing applications and many word processors. This example is taken from Windows Explorer. The rectangle has been dragged from the upper left to the lower right. So it starts from upper left to the lower right. A drag rectangle is dynamically sizable rectangle. Let's see. Whose upper left corner is the mouse down point, and then lower right corner is the mouse up point. So you release it at the lower right. When the mouse button is released, any and all objects enclosed within the drag rectangle are selected as a group. Visual indication of selection. Selected objects must be clearly, boldly, and indicated as such to users. The selected state must be easy to spot on a crowded screen, must be unambiguous, and must not obscure normally visible details of the objects. So the selected objects or the discrete data should be clearly and boldly. So it must be in bold. So it should be easily distinguished to others in a crowded screen. It should not be hard to synthesize, and must not obscure normally visible details of the object. Design principle: the selection state should be visually evident and ambiguous. You must ensure that, in particular, users can easily tell which items are selected and which are not. It's not good enough just to be able to see that the items are different. Keep in mind that a significant portion of the population is color blinded, so color alone is insufficient to distinguish between actions. Historically, inversion has been used to indicate selection, such as making white pixels and black pixels white. Although this visually bold, it is not necessarily very readable, especially when it comes to full color interfaces. Other approaches include colored backgrounds, outlines, pseudo 3D depression, handles, and animated marks. In drawing, painting, animation, and presentation application where users deal with visually rich objects, it's easy for selection to get lost. The best solution here is to add selection indicators to the object rather than merely indicating selection by changing any of the selected object's visual properties. So instead of just a visual indication, a solution for this sophisticated app is to add the selection indicators to the object. So most drawing applications take this approach with handles. So here is the handles, right? Little boxes that surround the selected object, providing points of control. So there. With irregularity shape selection, such as those in an image manipulation application like Adobe Photoshop, handles can be confusing and get lost in the clutter. However, there is one way to ensure that the selection will always be visible, regardless of the colors used. Indicate the selection by movement. So another technique is to indicate it by a movement. One of the first application on the Macintosh, MacPaint, had a wonderful idiom in which a selected object was outlined with a simple dash line. So selection movement, so that's a dash line, and the dashes all move in synchrony around the object. The dashes look like ants in a row, thus this effect earned the colorful sobriquet marking ants. Adobe uses this idiom to show selected regions of photographs, and it works extremely well. Expert users can toggle it off and on with a keystroke so that they can see their work without distraction. So it could be distracting to always show this, so you need to provide the balance. The animation is not hard to do, although it takes some care to get it right, and it works regardless of the color mix and intensity of the background. Insertion and replacement. If selection action involves creating or pasting new data or objects via keystrokes or paste command, they are somehow added to the selected object. So it's like, replacing that object in copy and paste. In discrete selection, one or more discrete objects are selected, and the incoming data is handled to the selected discrete objects, which process the data in their own way. So basically, it depends on how that object will process the incoming data. So it depends on how the application is programmed. So for discrete selection, such as discrete data, which process the data in their own way, this may cause a replacement action in which the incoming data or object replaces the selected object. Alternatively, the selected object may treat the incoming data in some predetermined way. In PowerPoint, for example, when a shape is selected, incoming keystrokes result in a text annotation of the selected shape. So when a shape is selected, any incoming keys will be added to that shape. So it's like you're typing. In continuous selection, however, the incoming data always replaces the current selected data. When you type in a word processor or text entry box, you replace what is selected with what you are typing. Contiguous selection exhibits a unique quirk. The selection can simply indicate a location between two elements of contiguous data rather than particular element of the data. This in between is called the insertion point. So here when I click, you see the hover, so that's the in between data. In a word processor, the caret, usually a blinking vertical line that indicates where the next character will go, indicate a position between two characters in the text without actually selecting either one. By pointing and clicking anywhere else, you can easily move the caret, but if you drag to extend the selection, the caret disappears and is replaced by contiguous selection of text. So here when I click and then here I drag, I was able to contiguously select the text. Spreadsheet also use contiguous selection but implement it somewhat differently. The selection is contiguous because the cells from a contiguous matrix of data, but there's no concept of selecting the space between two cells. So it's contiguous data, but there's no concept of clicking between the cells. So it also use actually Excel use also contiguous selection, in which like when you paste when you click and then paste it, it replaces it. In the spreadsheet, a single click selects exactly one whole cell. There is currently no concept of an insertion point in a spreadsheet, although the design possibilities are intriguing. Sorry, these are the one of the rare contiguous data app that does not insert the data when you click it, unlike in Word. That is, select the line between the top and the bottom of two vertically adjacent cells and start typing to insert a row and fill a new cell in a single action. So when you click the top and the bottom row and then paste it, your text there, you can possibly replace it. So those are the things that you could add. A blend of these two idioms is possible as well. In PowerPoint, slide sorter view, insertion point selection is allowed, but single slides can be selected too. So slide to sorter view or insertion point selection is allowed once you click on the middle of the text. But a single slide, you can also click a slide. If you click a slide, that slide is selected, but if you click in between two slides, a blinking insertion point caret is placed there. If an application allows an insertion point, contiguous objects must be selected by either clicking and dragging, or if they are part of the same logical group, by double or triple clicking. So if you're using a contiguous objects, it must be selected by clicking or dragging the object that you want to remove between there. Or if they're part logically, such as paragraph, double clicking or triple clicking would do. This means that the user will be doing quite a bit of clicking and dragging in the normal course of using application, with the side effect that any drag and drag idiom will be more difficult to express. You can see this in Word, where dragging and dropping text involve first a click and drag operation to make the selection, and then another mouse move back into the selection to click and drag again for the actual move. To do the same thing, Excel makes you find a special pliant zone, only a pixel or two wide, on border of the selected cell. To move a discrete selection, the user must click and drag the object in a single motion. So to move the discrete selection that you click in the middle of those two object in Excel, the user must click and drag the object in a single motion. To relieve the click and drag burden of selection in word processors, other direct manipulation shortcuts are also implemented, like double clicking to select a word. So those are the idioms that was the solution. Drag and drop. Of all the direct manipulation idioms, nothing distinguishes a WIMP more than the drag and drop operation. Clicking and holding the button while moving an object across the screen and releasing it in a meaningful manner uh, in a meaningful location. Surprisingly, drag and drop isn't used as widely as we'd like to think, and it certainly hasn't lived up to its full potential. We might define drag and drop as clicking an object and moving it to a new location, although that definition is somewhat narrow in scope for such a broad idiom. A more accurate description of drag and drop, clicking an object and moving to, imply a transformation. The Macintosh was the first successful system to offer drag and drop. It raised a lot of expectation with the idiom that were never fully realized for two simple reasons. First, drag and drop wasn't a system-wide facility, but rather an artifact of the Finder, a single application. Second, because the Mac was at the time single-tasking computer, the concept of drag and drop between applications didn't surface as an issue for many users. To Apple's credit, it described drag and drop in its first user interface standards guide. On the other side of the fence, Microsoft not only failed to put the drag and drop aids in its early releases of Windows, but also didn't even describe the procedure in its developer documentation. However, Microsoft eventually caught up and even pioneered some novel uses of the idiom, such as movable toolbars and dockable palettes. Generally, we use the term direct manipulation to refer to all kinds of GUI interaction idioms, but drag and drop has two levels of directness. First, with true direct manipulation idioms, dragging and dropping represent putting the object somewhere. Examples include moving a file between directories, opening a file in a specific application by dropping a file icon onto an application icon, or arranging objects on a canvas in a drawing application. The second type of drag and drop idiom is a little more indirect. The users drag the object to a specific area onto another object to perform a function. So here is the another way of doing the drag and drop, which is used to remain, but it's rarely used. These idioms are less popular but can be very useful. A good example of this can be found in the OS X Automator as shown in figure 18.18. So Apple's Automator tool in OS X allows user to set up common workflow such as renaming an image that are often represented as an icon. Users can then drag and drop files or folders onto the workflow icon to perform the function. While strictly speaking, this isn't direct manipulation, it does provide a reasonably direct way to invoke a command. Visual feedback for drag and drop. As soon as the user clicks the mouse button while the cursor on an object, that object becomes the source object for the duration of the drag and drop. As the user moves the mouse around with the button held down, the cursor passes over a variety of objects. It should be obvious which of these objects are meaningful drop targets. Until the button is released, these are called drop candidates. A drag can have only one source and one target, but there may be many candidates. The only task of each drag candidate is to visually indicate that the hotspot of the captive cursor is over it. This means that it will accept the drop or at least comprehend it if the user releases the mouse button. Such an indication by its nature is an active visual hinting. So design principle, drop candidates must visually indicate their receptivity. The weaker way to offer, the weakest way to offer the visual indication of receptivity to being dropped upon is by changing the cursor. So you should not change the cursor to indicate pliancy. The drag cursor design principle, the drag cursor must visually identify the source object. It's important that these two visual functions not be confined. Unfortunately, Microsoft seems to have done so in Windows, with its use of cursor hinting to indicate that something is not a drop target. This decision was likely uh, made more for the ease of coding than for any design considerations. It is much easier to change the cursor than it is to highlight drop candidates to show their drop receptivity. As if that wasn't bad enough, Microsoft performed this cursor hinting using the detestable circle with a bar, the universal icon for not permitted. This symbol is an unpleasant idiom because it tells user what they can do is unusual and could do irreparable harm. So after the user finally releases the mouse button, the current drop candidate becomes the target. If the user releases the mouse button on the interstice between valid drop candidates or over an invalid drop candidate, there's no target. Uh, and the drag and drop operation ends with no action. Silence or visual inactivity is a good way to indicate termination. Indicating pliancy, in an increasingly object oriented world, more things can be dragged than not. A cursor flicking and changing rapidly can be more visual distraction than help. So the cursor actually that blinks is a visual distraction, just like Adobe Photoshop that automatically blink or highlight the image. So it's not good for an expert user. One solution is to just assume that things can be dragged and let users experiment. This method is reasonably successful in the Windows Explorer and Macintosh Finder windows. Without cursor hinting, drag pliancy can be a hard to discover idiom. So you might consider building some other indication that the interface such as textual hint or tooltip or style pop up. Uh, so here when there that's an example of animation, guys. Oh my god, what's this? Just a moment, guys. It was deleted. Oh my god. Alright. hmm So let's continue. We just saw an example of another usability issues. So let's just drag this. Where's the saying? My god. See guys, how useful this knowledge is. There you go. So, where are we? So one solution is just to assume that the things can be dragged and let users experiment. This method is reasonably successful in Windows Explorer and Macintosh. Without cursor hinting, drag pliancy can be hard to discover idioms, so you might consider building some other indication into the interface, such as a textual hint or tooltip. So you can use tooltip for dragging or a textual hint. After the cursor object is picked up, the drag operation begins. There must be some visual indication of this. The most visually rich method is fully animate the drag operation, showing the entire source object moving in real time. One problem is that the drag operation can require a pretty precise pointer. For example, the source object may be 6 centimeters square, but it must be dropped on a target that is 1 centimeter square. The source object must not obscure the target, and because the source object is big enough to span multiple drop candidates, we need to use a cursor hotspot to precisely indicate which candidate it will be dropped on. So the size of the icon of the target should align with the source as well, because it could be so small that you could drop it to multiple target. This means that dragging a transparent outline or thumbnail of the object may be much better than actually dragging an exact image of the source object or data. So you can see that in an application where when you drag something, it's just the thumbnail of that application. Huh. Let's see. There. So, after the source object is picked up and drag operation begins, there's sorry. Where are we? This means that the dragging, transferring, or tumbling. It also means that the drag object can't obscure the normal arrow cursor. So the drag object or thumbnail should not obscure the cursor as well. The tip of the arrow is needed to indicate the exact hotspot. Dragging an outline also is appropriate for most repositioning because the outline can be moved relatively to the source object, still visible in its original position. So if you're dragging an outline, it's appropriate for most repositioning. Later we will discuss this further. because an outline can move relative to the source object, still visible in its original position, indicating drop candidacy. This drop must visually indicate that they are aware of being considered as potential drop targets. By visually changing the drop candidate, alerts users that they can do something constructive with the drop object. Of course, this requires that the software be smart enough to identify candidates, meaningful candidates, source target combination. A point so obvious that is difficult to see is that the only objects that can be dropped candidates are the ones that are currently visible. Usually, the number of objects occupying the screen real estate is very small, a couple dozen at most. This means that the implementation burden should not be overwhelming. Insertion targets. In some applications, the source object can be dropped into the spaces between other objects. Dragging text in a word is such an operation, as are most reordering operation in lists or arrays. So you can drag text as well in between. So dragging those is the same operation as what is done in list or array algorithms. In these cases, a special type of visual hinting is drawn on the background behind the GUI objects of the application or in its contiguous data. This is an insertion target. So a special type of visual hinting, which is the insertion target, when you insert it between contiguous data. Rearranging slides in PowerPoint, slide sorter view is a good example of this type of drag and drop. As the user drag, the insertion target, a vertical black bar that looks like a big text edit caret, appears between slides. Word 2 shows an insertion target when you drag text. So that's where you, when you click something, the blinking, not only is the loaded cursor apparent, but you also see a vertical dotted line bar showing the precise location between characters where the drop text will land. Whenever something can be dragged and dropped on the space between other objects, the application must show an insertion target, like a drop candidates in a source target drag and drop. So it actually mimics the source target in the drag and drop. Those click or the blinking click or vertical bar. The application must visually indicate where the drag and object can be dropped. Visual feedback at completion. A vital step is at this point is visual feedback that the operation has occurred. For example, if you're dragging a file from one directory to another, the source object must disappear from its source and reappear in the target. So it must be removed, of course, on the source. If the target represents a function rather than a container, such as print icon, the icon must visually hint that it received drop and is now printing. Auto-scrolling. What action should be the application take when the selected object is dragged beyond the border of the enclosing application? Of course, the object is being dropped to a new position, but is that new position inside or outside of the enclosing application? Take Microsoft Word, for example. When a piece of selected text is dragged outside the visible text window, is the user saying, I want to put the piece of text into another application? Or is he saying, I want to put this piece of text somewhere else in the same document, but that place is currently scrolled off the screen? But if the user desires the latter, the application must automatically auto-scroll in the direction of the drag to reposition the selection at distant, not currently visible location in the same document. Auto-scroll is a very important adjunct to drag and drop, wherever the drop target can possibly be scrolled off screen. The application needs to auto-scroll. Any design principle, any scrollable drag and drop target must be auto-scroll. So any scrollable drag and drop target must auto-scroll. So you must provide this variable auto-scroll, wherein when you are when I select that and then move the mouse up, it should automatically scroll. Basically, it begins Auto-scrolling just inside the application's border instead of outside the border, as the drag cursor approaches the border of the scrollable window but is still inside it. A scroll in the direction of the drag is initiated. If the drag cursor comes within about 30 pixels of the bottom of the text area, we'll begin to scroll the Windows content upward. So there's a measurement in which the word will become, or the application start to scroll upward. If the drag cursor comes equally close to the top edge of the text area, word scroll down. So thankfully, in recent times, developers have commonly implemented a variable auto scroll as shown in figure 18.9. The automatic scrolling increases in speed as the cursor gets closer to the Windows edge. For example, when the cursor is 30 pixels from the upper edge, the text scroll down at 1 line per second. At 15 pixels, the text scrolls at 2 lines per second, and so on. So you see how amazing that is. So that there is a program in which when the position locate or detects that, it will scroll accordingly. This gives users sufficient control over the auto scroll to make it useful in a variety of situations. Another important detail required by auto scrolling is a time delay. If auto scrolling begins as soon as the cursor enters the sensitive zone and around the edges, it's too easy for slow moving user to inadvertently auto scroll. To cure this, auto scrolling should begin only after the drag cursor has been in the auto scroll zone for a reasonable amount of time, but you should do that after some time, just like in the icon or tooltip. So figure 18.9, this image expresses the concept of variable speed auto scroll as it could be applied to Windows Explorer. Unfortunately, auto scroll moves at a single speed that is impossible to control. It would be better if the auto scroll went faster the closer the cursor gets to the Windows edge, but it's also important to have a speed limit. Auto scroll doesn't help anyone if it goes too fast. To its credit, Microsoft's idea of auto scrolling as the cursor approaches the inside edges of the enclosing scroll box rather than the outside is clever indeed. If the user drags the cursor completely outside word scrollable text window, no auto scrolling occurs. Instead, the repositioning operation terminates in an application other than the word. So it terminates in the other application if you move the object on another app such as PowerPoint. Avoiding drag and drop twitchiness. When an object can be either selected or dragged, it is vital that the mouse be biased toward the selection operation because it is so difficult to click something without inadvertently moving cursor a pixel or two. The frequent act of selecting something must not accidentally cause the application to misinterpret the action as the beginning of a drag and drop operation. So sometimes, because of this allowable operation, a click as or misinterpreted as a drag and drop. So the solution is that when an object can be either selected or dragged, it is vital that the mouse be biased towards selection operation. Because it's so difficult to click something without inadvertently moving the cursor a pixel or two. Users really want to drag an object only 1 or 2 pixels. So users doesn't usually want to drag an object 1 or 2 pixel only, and even in cases where users do, such as in drawing applications, it's useful to require a little extra effort to do so to prevent frequent accidental repositioning. In the hardware world, controls like push button that have mechanical contacts can exhibit what engineers call bounce. This keeps your stereo from turning back off a thousandth of a second after you turned it on. The situation is analogous to the oversensitive mouse problem. The solution is to copy switch makers and debounce the mouse. To avoid inadvertent repositioning, applications should establish a drag threshold. All mouse movement messages that arrive after the mouse down event are ignored, unless the movement exceeds a small threshold amount, such as 3 pixels. So if you drag it in just 3 pixels, then it won't be drag. If it's over that, then that's the time it will drag. This provides some protection against initiating an inadvertent drag operation. If the user keep the mouse button while 3 pixels of the mouse down point, the entire click action is interpreted as selection command. So if it's only within 3 pixels, it is interpreted as selection, and all tiny spurious moves are ignored. As soon as the mouse moves beyond the 3 pixel threshold, the application can confidently change the operation into a drag, as shown in figure 8.20. Any object that can be both selected and dragged must be debounced. When the user clicks the object, the action must be interpreted as selection rather than a drag. Even if the user accidentally moves the mouse a pixel or two between the click and the release, the application must ignore any mouse movement as long as it stays within uncommitted zone, which extend 3 pixels in each direction. After the cursor moves more than 3 pixels from the mouse down coordinate, the action changes to a drag and the object is considered in play. This is called a drag threshold. Design principle: debounce all drags. Some applications require a more complex drag threshold. 3D applications often require drag threshold that enable movement in 3 projected axes on the screen. Another such example arose in the design of a report generator for one of our clients. The user could reposition columns on the report by dragging them horizontally. For example, he could put the first name column to the left of the last name column by dragging it into position from anywhere in the column. This was by far the most frequently used drag and drop idiom. However, another infrequently used drag operation allowed the values in one column to be interfaced vertically with values of another column. For example, an address field and state field. So because of that infrequently controls, it actually makes the this drag movement. This report generation application offered an interesting feature that enables the contents of one column to be interspersed with the contents of another by dragging and dropping. This direct manipulation action conflicted with more frequent drag and drag action of reordering the columns, like moving a city to the left of address. We use a special 2-axis drag threshold to accomplish this. We want to follow the persona's mental model and enable him to drag the values of one column on top of the values of another to perform this stacking operation. However, this conflicted with a simple horizontal rendering of columns. We solved the problem by differentiating between horizontal drags and vertical drags. If the user dragged the column left or right, it meant that he was repositioning the column as a unit. If the user dragged the column up or down, it meant that he was interspersing the values of one column with values of another. So they solved this using horizontal and then vertical drag and drop, which means that they are repositioning the column as a unit. If the user dragged the column or down, it meant that he was interpreting the values of one column with the values of another. Because the horizontal drag was the predominant user action and vertical drags were rare, we bias the drag threshold toward the horizontal axis. Since the first and last name is always being connected, they use the horizontal axis as the default for dragging. Instead of a square uncommitted zone, we created the spool shape zone shown in figure 18.22. Because the horizontal motion threshold was set to 4 pixels, it didn't take a big movement to commit users to the normal horizontal move while still insulating users from inadvertent vertical move. So it's just 4 pixels. So again, 3 pixels is the minimum. To commit to the far less frequent vertical move, the user had to move the cursor 8 pixels on the vertical axis without deviating more than 4 pixels left or right. That motion is quite natural and easily learned. So because you need to move it whether it's left or right at the top, you need to move it 8 pixel. It's easy not to confuse that with horizontal, which is the most common command. Fine scrolling. The weakness of the mouse as a precision pointing tool is readily apparent, particularly when dragging objects around in drawing application. It is hard to drag something to the exact desired spot, especially when the screen resolution is 72 pixels per inch, or sometimes much more, and the mouse is running at 6:1 ratio to the screen. To move the cursor 1 pixel, you must move the mouse about 1 to 500 of an inch for this type of pixel. This is solved by adding a fine scrolling function, whereby users can quickly shift into a mode that allows much finer resolution for mouse-based manipulation of objects. During a drag, if the user decides that he needs more precise maneuvering, he can change the ratio of the mouse movement to the object's movement on the screen. So it allows you to configure the drag movement for drawing, since you need a more precise dragging. You don't need 3 pixels, you need a 1 pixel because of the 6:1 ratio to screen. An application that might demand a precise alignment must offer a fine scrolling facility. This include, at a minimum, all drawing, presentation, and image manipulation applications. This idiom has several variants. Commonly using a modifier key while dragging puts the mouse into a vernier mode, in which every 10 pixels of mouse movement are interpreted as a single pixels of object movement. So there's actually a vernier in which allows you to have modifier keys such as shift that allows the application to interpret every 10 pixels of mouse movement as a single pixel, so that you can more detailed manipulate the object. Any program application that demands precise alignment must offer a vernier. Another effective a vernier is just a modifier or a command that allows you to immediately configure the drag. Another effective method is to make the arrow keys active during a drag operation. While holding down the mouse button, the user can manipulate the arrow keys to move the selection up, down, left, or right, 1 pixel at a time. The drag operation is still terminated by releasing the mouse button. Many pixel pushing applications like Adobe Photoshop let users move selections by a single pixel with arrow keys, and by 10x the standard amount when modified with the shift key. The problem with vernier is the simple act of releasing the mouse button can often cause the user's hand to shift a pixel or two. This causes the perfectly placed object to slip out alignment just at the bottom of moment of acceptance. The solution is, upon receive the first vernier keystroke, to desensitize the mouse. The solution is, upon receipt of the first vernier keystroke, to desensitize the mouse. You can do so by making the mouse ignore all subsequent movements under some reasonable threshold, such as 5 pixels. This means that the user can make initial group movements with the mouse and then make a final precise placement with the arrow keys, and then release the mouse button without disturbing the placement. If the user wants to make additional gross movements after beginning the vernier, he simply moves the mouse beyond the threshold and the system shifts back out of vernier. If the arrow keys are not otherwise spoken for in the interface, as in a drawing application, they can be used to control vernier movement of the selected object. This means that the user does not have to hold down the mouse button. Adobe Illustrator and Photoshop do this, as does PowerPoint. In PowerPoint, the arrow keys move the selected object one step on the grid about 2 millimeters using default grid settings. If you hold down the Alt key while using the arrow keys, the movement is 1 pixel per arrow key. So I think we'll just continue with control manipulation until 3D in the next video. Thank you for watching, and see you on the next video. Peace.